Hello and welcome back to our channel. Today, we're going to explore one of the most crucial components in modern electronics, integrated circuits, or ICs. From your smartphone to your laptop, ICs are everywhere. Let's dive in and see how they work. So, what exactly is an integrated circuit? An IC is a set of electronic circuits on a small flat piece of semiconductor material, usually silicon. They can contain thousands, millions, or even billions of transistors, resistors, capacitors, and other components, all packed into a tiny chip. This miniaturization allows for incredible power and functionality in a very small space, making modern electronics compact and efficient. Integrated circuits were first developed in the late 1950s. The invention is credited to Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductor. Kilby demonstrated the first working IC in 1958, and Noyce's design in 1959 solved many practical problems, making mass production feasible. Since then, IC technology has advanced rapidly. From the early days of simple logic circuits, we've progressed to complex microprocessors and memory chips that power today's computers and devices. Integrated circuits come in various types, each serving different purposes. Let's look at some common ones. Analog ICs. Analog ICs process continuous signals. They are used in applications like audio amplification, radio frequency modulation, and power management. Digital ICs. Digital ICs work with binary data zeros and ones. They form the backbone of computers, smartphones, and digital communication systems. Mixed signal ICs. These ICs combine both analog and digital functions. Examples include analog to digital converters, ADCs, and digital to analog converters, DACs. The process of making an integrated circuit is incredibly complex and precise. It involves several steps, including photolithography, doping, etching, and packaging. In simple terms, a silicon wafer is coated with a photoresist layer, exposed to ultraviolet light through a mask, and then etched to create intricate patterns. This process is repeated multiple times to build up the layers of the IC. Finally, the wafer is cut into individual chips and packaged for use. Integrated circuits are found in almost every electronic device you can think of. Here are a few examples. Computers and laptops, microprocessors, memory chips, and graphics cards. Smartphones, processors, memory, and communication modules. Home appliances, control systems in washing machines, microwaves, and TVs. Automobiles, engine control units, infotainment systems, and safety features. Medical devices, pacemakers, diagnostic equipment, and imaging systems. The future of integrated circuits looks incredibly exciting. With advancements in nanotechnology and materials science, we're seeing the development of even smaller, more powerful ICs. Innovations like quantum computing and AI-driven processors are set to revolutionize the field. Integrated circuits truly are the building blocks of modern electronics, enabling the incredible technology we rely on every day. Thanks for joining us on this journey into the world of ICs. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content. See you next time.